Hello students, welcome back. Let us now go to section 4 of this notebook, variation. This topic corresponds to section 2.5 of our textbook, titled the same, variation. This is going to be a little bit different from the rest of chapter 2 in a sense that we do not deal with graphs. Then why is it included in chapter 2 titled graphs? That's what our textbook author did, and I did the same thing here. Section 4 appears in lesson 4 titled graphs. What's the relation? Geometrically, there is none. In terms of picture, that is. Algebraically, however, there is some relation. Here's an example, the simplest example, called a direct variation equation, y equals to kx, where x and y are variables that change, and k is a constant that doesn't change. So, we have an equation of two variables put together, and depending upon this k value, you're going to get a curve. In fact, the curve you're going to get is a line. Here's another example. This is called an inverse variation equation. Y equals k times 1 over x, or simply y equals k over x. Depending upon the k value, you're going to get a couple of curves, a pair of curves. This one here, the direct variation equation, corresponds to these kind of sentences. A quantity y varies directly with x, or simply, skipping this directly part, y varies with x. Or y is proportional to x. Proportional directly to x? That's an overkilling. I've never heard anybody saying that. So proportional to x or varies with x, they mean the same thing, and they all mean y equals to kx, direct multiplication. Here, x and y are variables that change, but k is a constant that doesn't change, and it is called the variation constant or the proportional constant. They are both widely accepted terms, so please remember both. Now the second equation down here is called an inverse variation equation, and it corresponds to sentences like y varies inversely with x. And in this case, you cannot skip inversely, because if you simply say y varies with x, that means a direct variation. So inversely part has to be emphasized accordingly. Same here, a quantity y is inversely proportional to x. So whether you use varies with or proportional to, you have to emphasize the inverse part. So alright, we went through some terms, and then we went through the variation equation, the direct equation, inverse variation equation, not indirect, inverse. But then again, how do we use these? How useful are they? Here are a couple of examples, and let's go through with these. It may be a good idea to start the playback and read through the problems first. Please do. Okay, here we go. The monthly mortgage payment M varies directly with the amount borrowed B. If a payment of a 30-year mortgage is $665 for every $1,000 borrowed, find the monthly payment when the borrowed amount is $120,000. This is a direct variation problem. The problem says so. Varies directly. And this corresponds to the direct multiplication. Now, how does it work? Y is kx alright? Then, please consider this kind of change. What happens to y if you double x? This will become what? It'll become 2y. Does it make sense? What if I triple the x? Then same here. Y is tripled. What if I quadruple y? x is also quadrupled. What if I half x? Then y is halved as well. What if I take 1/10 of y? Same thing for x. Am I making sense here? So exactly the same thing is taking place to the other character, the other variable, in terms of any coefficient, any multiplication. Let's go back to the problem. In this case, $1,000 borrowed is 120-folded. So what do you think will happen to the payment of $665 each month? Is it also 120-folded? It should. And that's the idea behind the direct variation. Here we go. Does it make sense? B is 120-folded. Therefore, M is also 120-folded. And calculate, you get $798 each month. Of course, if you add escrow, then the amount will increase. By the way, this method is a shortcut method. It gives you a good intuitive understanding about the direct variation, but it stops here. I do not recommend it because this is too simple. This problem by itself is not college-worthy. Real college-worthy problems are down here, joint variation, and this method, it doesn't extend. It works only for direct variation, only for a very, very simple example like this. But it does help you understand what it means by direct variation. That's why I went through it. One quantity is double, triple, quadrupled, exactly the same for the other variable. In this case, 120-folded. Okay, so much for example 1. Let's go to the second example here. The maximum weight W can be safely supported by a 2-inch by 4-inch piece of pine plank varies inversely with its length L. If the maximum support for a 10-foot long 2x4 piece of pine is 500 pounds, then what is the maximum weight support for the length of 25 feet? In this case, the maximum weight supported by this beam, 2x4-inch pine, varies inversely with the length. So the length is doubled, then the weight is going to be halved. You see, length is doubled, and then if you put heavy object right in the middle, it's more likely to break up. And actually, this is inverse variation, so the maximum support will be halved. Tripled, then the weight will become 1/3, and so on and so forth. Let's go to this, and then let's analyze the same way. K times 1/x, right? Okay. What if I double x? What happens to y? It becomes 1/2 y because this 2 down here will stay down there. What if I triple this? Then 1/3 it. Now, what if I take 1/10 of x? Then denominator goes on top, so this will become 10y, and so on and so forth, and vice versa as well. So that's the inverse variation, or inverse proportion. Let's come back to this problem. The length L is originally 10 foot long, and now 25 feet. So it's a little bit more than doubled, less than tripled, 2.5 folded. So what happens to the weight, which started as 500 pounds? Do we multiply? No, that's direct variation. We have to divide. If we double, then this will be halved. If you triple, then this will be 1/3. If it is 2.5 folded, then it will be 1 over 2.5 folded, as you can see here in this solution. 25 is 2.5 times 10. This is inverse variation, so we divide by 2.5, and there you go. Do you understand this idea? Again, a fair warning. Do not use this method because this is just too simple. It is just a stepping stone. And for much harder problems, this method is going to be unreliable. It's not going to be useful. But at this moment, you can intuitively understand what it means by inverse variation very easily this way. Same as that. Direct variation. If one quantity is double, triple, quadruple, tenfolded, exactly the same as the other variable, double, triple, quadrupled, hundredfolded. As for inverse variation, if one quantity is double, tripled, quadrupled, tenfolded, the other quantity, it should be 1/2, 1/3, 1/4, 1/10, like that. That's the distinction between the direct variation and inverse variation. And these examples are uses of those variations. As you can see in this example, they're useful in real-life application. Now, those are for shortcut methods, a good way to understand the variation concept intuitively, but it's not really standard and it's not going to be that useful for much harder problems. We're going to discuss the standard method in a separate video because it's going to be a long story on its own.